Our second exercise contains two applications, one with DC voltage and the other with AC voltage. We will not read the questions because we'll be reading them one by one in each part. But in general, we have two waveforms, 1 and 2, representing two voltages, UAB and UCD. The first one here goes for UAB and this one goes for UCD. In the absence of any voltage, the horizontal line passes through the center, again setting our reference. The vertical sensitivity on both channels, usually an oscilloscope has two channels, it can measure two voltages. So when you read two channels, it is simply for each outlet you use or for each channel you are using. Starting with part 1, exploitation of waveform 1, which is voltage UAB, if you recall. First part, give the type of the voltage represented by the waveform. Simply, it is a DC constant voltage or simply DC voltage because the displayed oscillogram, is a straight line. Oscillogram is a straight line. If you'd like to explain more, a straight horizontal line. We have to add that, yes, because it is constant because it's horizontal line. Now, if you just say DC, it's also accepted. Nevertheless, the word DC means constant direction. So when you say direct, it is always either positive or negative. But over here, it's not only positive or negative, or specifically negative, it is constant as well. So that's why we added here another description, which is not only DC, but constant as well. Part 2. The value of the voltage is negative. Why is that? Because the line is displaced downwards. Okay? Below the, you can say the x-axis, or below the axis simply, which is the time axis. Or simply you can say because it is displaced towards the negative region. Let's add this with a different color. Downwards or towards the negative region. The negative region. It's also acceptable. Now, part 3. Determine the value UAB. Directly, UAB in volt, as we know the equation of the oscilloscope voltage, is Y in division times SV in volt per division. You notice here I'm moving a bit faster because this is our second exercise. Now Y here is, let's count, negative, notice, 1 division, 2 divisions, and here it's almost half or less. As I can see, now you can enlarge the picture, it is on the second subdivision, which means this is 2.4. So let's write this as a note. Second subdivision, then 0.4 and not 0.2. Keep that in mind. Multiplied by 5, which is minus 12 volts. So the voltage is 12 volts, but displayed in the negative region. In the negative region. I always like to give the negative sign a meaning so that it doesn't just be it's not just treated as a regular number. 4. Is the phase of the oscilloscope connected to point A or a point B? Now, we are not given whether A or B are negative, but we know that the waveform is UAB. Now, the oscilloscope usually reads or displays, better than reads, let's just erase it and write displays, displays the voltage from the phase to ground. That means, which is UAB, so A is connected to the phase. phase, or simply phase is connected to A. Part 5, give the name of a source of tension that may deliver such a voltage, a dry cell. You can also say a battery, an accumulator, a galvanic cell, solar panel, whatever you want. Dry cell is the best, I think. Let's move to the second part. Exploitation of waveform 2, which we know is voltage UCD as indicated later. Give the type of this voltage. Simply this voltage is alternating because it's taking positive and negative values, and since shape is like a wave, so it's alternating sinusoidal. Now, we don't need to explain because it's not required. If you want to say, you can say wave-like form taking positive and negative values. Okay, but you don't need to do that values, so we don't need it. If we continue, part 2, determine the maximum voltage Umax of CD in volt equals Ymax in divisions multiplied by SV in volt per division. Now, before I move on, I know that I always emphasize on writing these units, but since we have used the same equation in part 1, you could have simply written the equation without the units. It's fine. Y is also 2.4 because if you count from here to the top, it's almost the same as the previous one, I mean, multiplied by 5, so it equals to 12 volts. So UCD max is 12 volts. A question I always know that they're going to ask after Umax whenever we have sinusoidal voltage is deducing the effective value. We can go directly to answer the question. For alternating sinusoidal, voltage, what do we know? Voltage. We know that U effective equals U max over square root of 2, which equals to 12 over radical 2. U effective is almost 8.36, 8.4 volts. And that's it. Now, passing to the third part, which is a comparison between these two waveforms or waves or voltages that we got. Feeding a lamp. Consider a lamp labeled by 12 volts. Now, what does this label mean? What does the indication 12 volt represent on the lamp or for this lamp? Simply 12 volts is the rated voltage of the lamp. If you'd like to explain more, what does rated voltage of the lamp mean? You can add, let me add this with different color because it's not obligatory. It is the voltage needed by the lamp to light up or to glow normally. Needed by the lamp to glow or to function normally. Okay, no need to write that. That's why we have written it with a different color. Part 2a. Upon feeding this lamp successively with the voltages, L functions normally under the voltage UAB. Now UAB equals minus 12 volts, which is equal to 12 volts of the lamp. Here you might ask, how is the minus 12 equal to 12? Simply because the lamp has no polarity. So whether you give it 12 or minus 12 are the same for it. Okay? So if you just say the lamp functions normally because it's receiving 12 volts, you get a full grade. And if you'd like to explain more, we did that. So minus 12 or 12 are alike for a lamp. It doesn't matter how you give the voltage to the lamp. Positive, negative, negative, positive, it's the same thing. Now, it does not function normally under voltage UCD because simply in AC mode, the lamp functions according to an effective value. Functions according to effective U effective voltage. Now U effective equals 8.4 volt is less than U rated, which is 12 volts. 12 volt, I skipped the V. So the lamp gives a dim light. Okay, or simply functions dimly, glows dimly, or does not function normally. This is the second exercise. I think it is clear. I think if you have managed and reached solving this exercise flawlessly, then you are more than ready to sit for any exam that you like. That's it concerning the exercises. Thank you for your time. I hope that you were able to understand how to solve more related to the AC voltage exercises. And in case of any question, don't hesitate to ask it.